All right, good morning. So we're going to continue with our lesson on Intro to Limits. Yesterday, just to recap, we talked about limits as existing only if we are approaching a specific number. We discussed how you can have types of discontinuity which can cause a limit to not exist, but if you ever have indeterminate form, remember that's when you plug in a value into a function and you get the result as 0 over 0, that's your whole or removable discontinuity. You can still have a limit that would exist. We looked at the differences whenever you have results with 0. In the numerator, it's 0. In the denominator, it's undefined. And if it's in both the numerator and the denominator, then we call that indeterminate form. All right, so these are some of the results that we're going to be looking at today when we get into problem solving, and that's going to be our next step. I did want to review this little concept because we didn't do it in class. So if y'all can take a look right here at this table. And in this table, I'm just going to talk you through it real quickly. You can get your calculator out and put numbers in to test it if you want to. But what we're doing is we are taking this original problem that we had, this function rule 1 over x minus 5, and we already talked about what's happening as x approaches 5. We already graphed it and realized there was an asymptote there, and anytime there's an asymptote, you're going to have discontinuity, okay, infinite discontinuity. And the reason why there's infinite discontinuity without having to graph it is when you plug that 5 in, your result is 1 over 0. That's undefined. Undefined represents this asymptote. Okay, so to talk just a little bit more about that, if you were looking at this table, if you were to plug these numbers back into this equation, and I want you to look at them. We are approaching 5. This is how it says as we're approaching 5, and I want you to look at these numbers, how they're changing, getting closer and closer to 5. And this side over here is approaching from the left. Approaching from left. Right here. This portion we are approaching from right. And when I say that, I want to make sure you understand what that means is if we are approaching 5 from the left. Give me a time out here just 1 second. Sorry for that pause. But I want you to realize that in these values right here, when we say we're approaching from the left, that's this side right here. Okay? And as we're approaching from the right, that's this side right here. And when you plug these numbers in back into the function rule, your result is a negative 1. We plug in negative 4.5, we're getting bigger. Negative 2. Negative 10. 4.99, we get a negative 100. So I want you to notice that we are getting smaller and smaller right here. This is showing that we are approaching negative infinity. My colors aren't showing up very well. Approaching negative infinity. And if you look at the graph, it shows that we are approaching negative infinity from the left. All right, now, if we plug in these numbers on the right, 5.01, we have a positive 100. 5.1 is a 10. And then 5.5 is positive 2. I want you to see as we are approaching from the right that we are getting infinitely bigger. So we are approaching positive infinity. Let's use my little symbols there to make it a little quicker. And if you look on the graph, we are approaching positive infinity. So these are just different ways to symbolize, to understand what's happening, be it if you have a graph, if you have a function rule, whatever the case may be. And this next question asks, what is the behavior of f of x as x approaches 5 from the positive or negative side? Okay, well, to summarize this table in words, we would say as x approaches 5 from the negative side. Okay, remember we did this little notation yesterday. It looks like it's in the exponent. As we are approaching negative 5 from the right, the equation, the function rule, is approaching negative infinity. This is on the negative side. And over here on the positive side, when we're approaching the right, as x is approaching 5 from the positive side, y is approaching positive infinity. This is on the positive side. So I want to make sure you understand that this is talking about the side that we start on. So we are on the positive side of the asymptote, headed to positive infinity. This is on the negative side of the asymptote, and we're headed to negative infinity. All right. Now, we'll skip back over. Now, here comes the big math part where we have to start solving equations. And this is where some of you might start to struggle a little bit. It pulls in a lot of algebra. So when you are looking to see if a limit exists, what you can do from the very start is plug in the 1, plug in the value, the constant, into the equation and see what you get out. That's a quick way to know, hey, is there going to be an asymptote? Is there going to be a hole? What's happening at this position? Because if you can identify that at the very beginning, it'll save you some time and trouble. All right, so if I plug in a 1, just eyeball that, I've got 1 plus 1 minus 2 at the top, 1 minus 3 plus 2 at the bottom. This ends up being 0 over 0. This is going to be indeterminate form. What does that mean? Indeterminate. I can't spell. I got to do phonics. Form. It means there's a hole. So if there's a hole, there's a common factor. Okay? Indeterminate form. So we got to find the common factor before we do anything else. So here's what we're going to do, and I want you to pay attention to the way I write this out because you will be graded on this. All right? As long as we are looking for a limit, you have to continually write the limit notation. Now I'm going to go ahead and factor out my quadratic at the top. This would be x plus 2, x minus 1, and my factor at the bottom. This would be x minus 2, x minus 1. Once I factor that out, I can see there my common factor is x minus 1. So I'm going to take that out and then rewrite it as the limit as x approaches 1 of x plus 2 over x minus 2. Now, once I plug in the 1, you can do that mentally or you can rewrite it out. But if I plug in that 1, for both of these values, I've got 3 over negative 1, and that's going to be just negative 3. So you can do some mental math there if you need to. All right. So the limit as x approaches 1 for this function, and I'm going to just write for f of x, just for simplicity's sake, equals negative 3. This is what we're approaching for the x value, and this is where the graph is headed as far as the output value, the y-axis goes. And once you've done this, you can graph in your calculator to verify. Now, are you going to be able to do this on a test? Probably not. Graph and calculator to verify, but as you're learning it, to feel comfortable with it, you just want to kind of double check to make sure that you're doing what you need to do. All right, now I'm more focused on the math right here, making sure y'all know how to work with these ugly type functions. In this situation right here, what you've got is a fraction within a fraction. You got to get rid of that. If we plug in the 2, you can see that you're going to end up with 0 in both the numerator and denominator. So this is going to be a common factor, because we've got a whole or indeterminate form. Write whatever you need to do to make sure you understand why we're doing what we're doing. So what I'm going to start off with is finding a common denominator. Now, there are a couple approaches you can take with this, but what I'm going to do is I'm going to go ahead and take a look and see what would give me a common denominator just right here in my numerator. And my numerator common denominator is going to be 2x. Now, I'm going to multiply both my numerator and my denominator. My numerator of my main fraction, so this whole section right up here, and then my denominator. Some people will just focus on the numerator only, but you tend to have to work with fractions a little bit longer. By doing it this particular way, you kind of get rid of those fractions and it'll make it a little bit easier. So the limit as x approaches 2 for 1 over x minus 1/2 divided by x minus 2, this is our original function, I'm going to multiply that by my common factor or my common denominator of 2x. And I'm going to draw this little 1 around it, a big fat 1, just to remember that that's what I'm doing, is I'm multiplying my original function by something equivalent to 1. Now, I'm going to do the math work to simplify that. Make sure your work is nice and neat. So when I distribute the 2x over here to this term, I'm going to end up with 2 on top, and my x's are going to cancel, so I'll just end up with a 2. When I multiply 1/2 by 2x, my 2's will cancel, and I'm just going to end up with an x. So I'll have 2 minus x in my numerator, and then in my denominator, what I'm going to do is I'm going to go ahead and keep this in factored form and not distribute. The reason why is because we know we have a common factor. So if I multiply it all out, I won't actually see what my common factor is. Now, these two expressions right here, x minus 2 and 2 minus x, these are not the same. This one has a negative x. So what I'm going to do is I'm going to rewrite this. Oops, sorry, forgot my little 2 right there. I'm going to rewrite this and factor out the negative, because to be a common factor, I need to have a positive x and a negative 2. So if I factor out a negative 1, I'm going to be left with a positive x minus 2 in my numerator, and then I've got 2x times x minus 2 in my denominator. We've got our common factor. That cancels out, but this is what you need to be careful of, is that negative right there. You're left with a negative 1 in your numerator. So we've got the limit as x approaches 2 of a negative 1 over 2x. Now you're ready to take your limit, You're going to plug the 2 in for x, and you're going to get a negative 1/4. And so your final result is the limit as x approaches 2 for the function is a negative 1/4. All right. Number 9, just got a couple more scenarios, so all this is practice. You can work on these on your own, but I do want to make sure that y'all understand kind of how to do this a little bit better. I'm going to do, this will probably be the last one that I do, and then I will just post my key so that y'all can look at the key and if you need help on any of the others. All right, so number 9, we've got a quadratic here, right? But there's really no reason to factor this. Number 1, there's no fractions, so I'm not going to get indeterminate form. I'm not going to get an undefined. I'm going to plug negative 2 straight in. I'm going to make a note of that. Plug negative 2 straight in for x. So when I do that, plug in negative 2. Here we've got the limit as x approaches negative 2. Now this is where the math gets ugly and people will mess up with their order of operations. That's a negative. Then I'm plugging in a negative 2 and I'm squaring the negative 2. We are not squaring this negative out in front. Okay? If we were, then we would have parentheses around the whole thing. But we don't. So you want to make sure and pay attention to that, because your result is going to be a negative 4 plus 4, which is 0. Now, 0 is a value. It's a number. I don't want you to look at that and say, oh no, we don't have a value. It doesn't exist. Oh no, a limit does exist. And the limit as x approaches negative 2 for the function is just 0. All right, so now I'm going to pause. I'm going to stop. I'm going to post this video, and what I would like for y'all to do is I would like for y'all to practice these problems on the back page. Okay, see what you can do with those, and I'll have my answer key posted. But I also want you to take a look at this very last problem down here, number 13. Because number 13 is going to be a lot what your assignment's going to be about as well. And this is being able to analyze what's happening in the graph. So when you look at the graph and then look back here and see the limit notation to see where a limit exists, this particular problem right here, and I need to zoom in on that, the copying is terrible, copy quality. This is a negative 1 from the negative side, which means I am approaching negative 1 right here from this negative side. And as I am approaching from that side, my y value is approaching a positive 1. Because I'm just talking about just this one side. However, on part B is saying, well, what happens as you approach negative 1 from the right side? And as I'm approaching it from the right side, over here, the function is approaching negative 2. So the function is approaching negative 2. Because I am approaching two different destinations, when I ask about what the limit is as x approaches negative 1, this sucker does not exist, because when we're looking at both sides together, we are not approaching the same destination, and so therefore it does not exist. So I just need to make sure y'all understand the difference in the way these questions are being asked. Now, this last one is saying, what is h of negative 1? So basically, this means if I plug negative 1 into my function rule, what would the output be? What is the solution? So this is nothing to do with the limit. This just wants to know what the value of y is when x is negative 1. So when I look over here, and this is a jump discontinuity, but notice you have this point filled in right here. That's your output. That is your solution. So it's different from the limit. Okay? The limit doesn't exist, but an actual value does, and the actual value is 1. All right, so you're going to be looking at, I want you to do the same thing on your own and check your answers with this next portion as x is approaching 3. And then y'all will be done for the day. Y'all have a good day.